Of course, CoLab is provided by Google. So first of all, you have a Google account, okay? So here is an example, okay? I'd like to show you this one, GPU test. IPYNB stands for Interactive Python Notebook, okay? So you can simply just click it, okay? If you click the link, okay, and your browser has already logged into your Google account, it should be look like this, okay? There are several things you need to understand. The first thing is it looks like an editor, right? At the left-hand side, there are several tabs, okay, you may use. The other way, you can simply just type colab.research.google.com, okay, and it shows this interface. Open this IPYNB file from my Google Drive. Okay. The interface is the same. Okay, either you click the link or you directly go to colab.research.google.com and open a file from your Google Drive. Okay, there are several settings. For example, we want a light theme or dark theme or something like that. It is free for everyone. However, if you want to pay, okay, there are several features that you can use if you pay Google. Okay. At the right hand side, okay, there are two different blocks, okay, you can use. The first one is called code, the second one called text, okay. So, for example, if my cursor, okay, is at the very first block, okay, I can simply add code, okay, it's right here. So you can type your code in this block, or you can click text right here, and you can type whatever you want, okay, make a note, make a comment, okay, right here. At the right hand side, upper right hand side, here is a button right here. So you can open all those menus, okay? And one thing you have to notice is that, okay, depend on your language, okay? Currently my interface is traditional Chinese, right? So you can, right here, you can change it to English version. Okay, here's another tab which is very important, okay, before you execute your code, which is runtime. The execution model of CoLab is a little bit different from what you execute in your computer. So here I give you a brief introduction how those codes are executed. So here is internet. So somewhere there is a Google server, certain Google server on the internet, right? It's your PC. So you have a browser. So on this server, okay, right? That is code, that is software, that is software, that is hardware. For each CoLab, when you connect it to a CoLab, okay, the CoLab will assign a kernel for you. Kernel is a software. Kernel is a process that helps you to execute your code. So basically, when you create a new block right here, okay, say, okay, I would like to print something, ABC. You input your code in your browser, okay? So your browser will communicate with the remote kernel. So this part of code will be transferred to the kernel that assigned to your browser. Okay, so it received print ABC, for example. So the kernel will execute this part of code right here. So in the server, okay, there should be some CPU, okay, some RAM memory, or even some GPU, which helps you to execute those code. So those code will be uploaded to the kernel, to the CoLab server directly, automatically, and execute those codes on the remote server on their CPU. So after that, okay, the execution result will be returned to the kernel, and kernel will transfer those results back to your browser and show your result next to your code. So basically, your browser is merely just an input tool, okay? It's just a GUI tool that accepts your code and send a code to a remote CoLab kernel. And kernel will execute those code, get a result, and send the result back to your browser. And your browser will show those results next to your code. So basically, you don't use your own CPU, use your own RAM. You don't use your own GPU. The remote GPU, RAM, CPU is provided by Google for free. So that is the execution model of CoLab. So you may leverage these things. There is a setting for runtime. It's right here. Change runtime time. Okay. There are several hardware accelerator right here. Okay, here is a drop-down menu. None, GPU or TPU. When you select none, that means your code will be executed in the remote CPU. Of course, there's some, if you just simply write a very simple code, you can simply just choose this one, none. Okay. However, if you need to run some AI program, which need a lot of computation power, you need the help of GPU. You may select GPU right here, so that your code will be executed much faster when you select this GPU. Of course, there are certain specific device which is designed for TensorFlow. Okay, you may choose TPU. Okay, if you have any question, just click this more information. Okay, here I would like to demonstrate what is the difference between you use CPU and you use GPU. So I select GPU right here and I save this setting. I wrote this GPU test program. So just take a look at this one. How do we execute a code right here? Because it's right here in this second block. Okay, you can simply just click Control Enter, okay, or Command Enter to execute this block. So you can see that it's running, and at the right hand side right here, it's called editing, and how many RAMs you use in a remote kernel, how many disks you use in a remote CoLab server. If the block has been executed, it will be like this. So the result will be right here. The result returned by the kernel will be right here. In this block, which I print is, I want to know the current version of TensorFlow, which is a very important AI tool provided by Google. The current TensorFlow version, which I use in this CoLab, is 2.4.1. After you execute it, all the memories, all the execution state will be stored in the remote server and will be kept in the server until you close this tab. Currently, the kernel is up and wait for your next execution instruction. Okay, so the next one is this one. So I use Control Enter to execute this block. Okay, it's running. So currently, this code will be passed to the remote kernel, and here is the return value. I print two different things. Okay, the first one is, well, I would like to list all the physical device. Physical device right here means what is the CPU or GPU provided by the Google. So currently you can see that Google provides me a physical device, which is its name is CPU 0. The type is CPU. And the second one is GPU 0, and the type is GPU. So in this CoLab, I have two devices which can execute my code. One is GPU, the other is CPU. That is the physical device. So the other one is the logic device. Okay, here is CPU 0 and GPU 0 as well. The difference between physical device and logical device is you can combine lots of physical device to create a logical device. So like you can use two physical GPU and combine them into one logical device. And when you run your program on this logical device, okay, it can leverage two physical GPUs if you want to do so. Okay, so currently I have two devices, GPU and CPU. Here is the note /CPU 0, which is the CPU name of my kernel. GPU 0. So in TensorFlow, okay, we both have this implementation. Okay, I would like to show you what is the difference between using CPU or GPU to execute your program. So here is a very simple function. The function, I randomly create two matrices right here, and I do matrix product, okay, matrix product right here. So I want to get an answer right here. So it's a very simple function. I'd like to measure what is the time spent by executing this function. So when I execute the function here, line number 7, I ask to do those computation by using GPU, and the other in line 8 by using CPU. I will not go over all those code. Okay, you can just read those code. Okay, make sure you comprehend those code. Okay. So and here I wrote a load right here. Here is the size of that matrix from 0 to 500 by 500, 1000 by 1000 to 4000 by 4000. So basically, at the end, okay, I would like to multiplex two matrices. Each one is 4000 by 4000. It is a very large matrix. So here's the result. The blue line is the execution time of using GPU. Okay, the orange line is the result using CPU. So the x-axis is the size of the matrix. So when you increase the size of the matrix, okay, from 0, 500, blah, 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 to 4000, okay, you can see that the orange line, which is the execution time of CPU, is somehow like a linear time span, right? Which means when the size of your matrix is much, much bigger, the time you spend to execute by CPU is much longer. The relation is like linear. Because when you do the product computation, GPU has many small executor on the GPU. Each executor can independently execute the product. So which is much more efficient than using CPU. CPU has only one executor to do the product computation. But GPU has, I think, more than thousands of small executors which can do this execution. So basically, if possible, make sure your runtime has changed to GPU if you want to do a large amount of computation. When you open these things, if you want to try these things or you want to copy those CoLab file, here is the file, and you can save a copy in Drive. That means in your Google Drive, not mine. Okay, you can save a copy in your Google Drive. So you can save a copy and make your own comment, make your own annotation. Okay, so which is more convenient for you. Or you can save it to GitHub if you have GitHub. Here are some items right here. For example, if you like to execute all the blocks at once, so here is the run all or run before. Okay, if I put my cursor right here in this block and I select runtime, run before, only the blocks before your cursor will be executed. Sometimes the kernel in the remote CoLab server might crash. So at this moment, you can interrupt the execution and restart the runtime. Restart the runtime means kill the runtime kernel at the remote server, and the CoLab server will set a new kernel for you. But however, the execution in the RAM will be disappeared. Okay, that's all.